In this module, we will discuss different kinds of force actions through either contact or action at a distance, and also discuss direct versus indirect action. So we can classify forces and sometimes torques of two types. One is called action at a distance, which might be invisible but definitely real. And other is through direct contact, which means one material or object is visibly touching another object. So the first type of classification we'll discuss is action at a distance. And the best example of this one in our course is gravity. We all know that gravity acts on all of our bodies, but we don't actually see it or feel it directly touching us. But it's definitely there. So gravity is acting from a distance, in this case originating from the weight at the center of the Earth. Gravity is considered always to be external to a body. Near the Earth's surface, gravity acts straight downward, and its magnitude is equal to the object's weight. The weight of a body, as we will see, never acts on another body. So here's an illustration. I think you know from physics that the weight is equal to the mass times the gravitational constant. And I'll ask if you can think of any other types of forces that act at a distance. The other kind of forces are what we'll call contact forces, in which case you have a material touching another material object. And this is very common, especially in engineering situations. And here are some examples. You could have surface-to-surface contact, where you have two flat and maybe curved surfaces that are in contact with each other, causing both normal forces and possibly tangential forces relative to the contact surface. Or if we're more technical, sometimes we talk about the tangent plane. Friction is a tangential force, meaning it acts parallel to the surface of contact. Different kinds of structural elements, cables, rods, and springs we'll be discussing pretty soon, and those are able to transmit forces, as you'll see, forces that are parallel to those objects. And different kinds of connectors. Forces can be transmitted through things like pins and hinges that might connect one body to another, and connectors like welds and plates can transmit both forces and torques. The next thing we'll discuss is direct versus indirect action. When we select a system to study, we need to be very careful when we draw its free body diagram. We must draw all of the forces and torques that act directly on the system, and only the forces and torques that directly act on that system. Be very careful to avoid forces that indirectly interact with the system that you select. So, for example, and I'll see if you can intuitively discover this partly on your own without further comment from me, but imagine you have a box, and inside the box there are a bunch of smooth pebbles. So smooth is another way of saying frictionless. And let's say each pebble has a weight. Now the objective here would be to draw the free body diagram of the object B. And the question you should be asking is, what do you think is acting directly on that object? And that's all that you would draw on that object. And I'll acknowledge I took this problem from another page at the Open Learning Initiative at Carnegie Mellon University. So here are some examples of how you might draw the free body diagram of that object, and I'll say one of these would be accepted as valid, and all of the other ones have at least one error.